Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
O'Reilly!
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
This is SpaceTime Series 25, Episode 18, for broadcast on the 11th of February 2022. Coming up on SpaceTime, a new theory to explain how the Moon's crust was formed, an update on the Lunar Gateway space station project, and a new joint Russian and Chinese moon base to be operational by 2035. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
A new study has shown how freezing a slushy magma ocean may be responsible for the composition of the Moon's crust. The findings, reported in the journal Geophysical Review Letters, suggest that the lunar crust can best be explained through crystallization, where crystals remain suspended in liquid magma for hundreds of millions of years as a sort of lunar slush, frozen solidified. Over 50 years ago, Apollo astronauts collected samples from the lunar highlands. These large pale regions of the Moon, visible with the unaided eye from Earth, are made up of relatively light rocks called anorthosites. Anorthosites formed early in the history of the Moon, between 4.3 and 4.5 billion years ago. Similar anorthosites formed through the crystallization of magma can be found in fossilized magma chambers on Earth. Producing large volumes of anorthosite found on the Moon, however, would have required a huge global magma ocean. Scientists believe that the Earth's moon formed when a Mars-sized planet called Theia collided with the early proto-Earth, melting both bodies and creating a protoplanetary magma ocean, which eventually coalesced and solidified to form the Earth as we know it today. Ejecta flung into orbit during that collision would coalesce to form the Moon, which would also have started out as a mostly molten magma ocean. Now, since the Apollo era, it had been thought that the lunar crust was formed by light anorthite crystals floating at the surface of the liquid magma ocean, with heavier crystals solidifying at the ocean floor. This flotation model explains how the lunar highlands may have formed. However, since the Apollo missions, many of the lunar meteorites which have made their way to Earth have been analysed, and the surface of the Moon has been extensively studied in far more detail. And it seems lunar anorthosites appear to be more heterogeneous in their composition than the original Apollo samples, which contradicts the flotation scenario, where the liquid ocean is the common source of all anorthosites. The range of anorthosite ages, over 200 million years, is difficult to reconcile with an ocean of essentially liquid magma whose characteristic solidification time is close to 100 million years. One of the study's authors, Jerome Neufeld from Cambridge University, says given the range of ages and compositions of the anorthosites on the Moon, and what science knows about how crystals settle in solidifying magma, the lunar crust must have formed through some other mechanism. So the authors have developed a new mathematical model to try and identify what this mechanism is. Neufeld and colleagues found that in the lower lunar gravity, the settling of crystals is difficult, especially when strongly stirred by a convecting magma ocean. If the crystals remain suspended as a crystal slurry, then when the crystal content of the slurry exceeds a critical threshold, the slurry becomes thick and sticky, and the deformation is slow. Now, this increase in crystal content occurs most dramatically near the surface, where the slurry magma is cooled, resulting in a hot, well-mixed slurry interior and a slowly moving crystal-rich lid. Neufeld and colleagues believe that it's in this stagnant lid that the lunar crust formed, as lightweight anorthite-enriched melt percolated up from the convecting crystalline slurry below. They suggest that the cooling of the early magma ocean on the Moon drove such vigorous convection that crystals remained suspended as a slurry. Enriched lunar surface rocks likely formed in magma chambers within this lid, which then explains their diversity. The results also suggest that the timescale of lunar crust formation is several hundred million years, which just happens to correspond with the observed ages of lunar and north sites. This is SpaceTime. Still to come, we update you on the Lunar Gateway project to build a space station between the Earth and the Moon. And speaking of space stations, a joint Russian and Chinese moon base is expected to be operational by 2035. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, NordVPN. You know, I love NordVPN because it gives me access to all my favorite streaming sites, social media platforms, and messaging apps without needing to worry about being hacked or having my data stolen. And the reason's very simple. NordVPN is the fastest virtual private network on the planet. They have over 5,300 servers worldwide and the game-changing NordLynx protocol, which lets me stay safe online without slowing me down. And NordVPN's also super easy to use with its Quick Connect feature that finds the best server options for me at any given moment. Then there's the secure access to streaming websites, social media, and messaging platforms, all without needing to worry about my privacy or security. And you can experience the same freedom today by signing up for our special SpaceTime offer. To grab this exclusive NordVPN deal, go to nordvpn.com/StuartGary or use the code StuartGary and get a huge discount off your NordVPN 2-year plan, plus one additional month for free and a bonus gift. Now, it's all completely risk-free and it comes with Nord's 30-day money-back guarantee. So, what have you got to lose? Grab your exclusive NordVPN deal today by going to nordvpn.com/StuartGary or use the code StuartGary to get a huge discount off your NordVPN 2-year plan, plus one additional month for free and a bonus gift. And it's all completely risk-free with Nord's 30-day money-back guarantee. And of course, we'll include the link in the show notes and on our website. And now, it's back to the show.
You're listening to SpaceTime with Stuart Gary.
Canadian Prime Minister Justin Trudeau has formally signed Canada up to America's Lunar Gateway project. Canadian Space Agency will build a next-generation Canadarm for NASA's next orbiting outpost. The Lunar Orbital Platform, or Gateway, is a project by NASA and its international partners to develop a lunar orbit space station which will function as a staging post for future missions down to the lunar surface and eventually onto the red planet Mars. The platform will include a solar-powered communications hub, a science laboratory, a short-term habitation module, and a holding area for rovers and other robotic equipment. Gateway will focus on planetary science, astrophysics, Earth observations, heliophysics, fundamental space biology, and human health and performance in space. It'll also serve as the staging point for deep space transport craft to perform a 300 to 400 day shakedown mission prior to NASA's first manned missions to Mars. The project was originally called Deep Space Gateway. It was intended for the now cancelled Asteroid Redirect mission to move a near-Earth asteroid into a near-lunar orbit. When it's built, the Lunar Gateway will be placed in a highly elliptical halo orbit at the Earth-Moon Lagrangian or L1 position. It's a point in space where the gravitational pull of the Earth and the Moon balance each other out, allowing a spacecraft to remain in that relative position with little need for orbital maneuvering propulsion for station keeping. The halo orbit would keep Gateway between 1,500 and 70,000 kilometres of the lunar surface over a continuous 6-day cycle. The space station would centre around its Power and Propulsion Element or PPE module, which would include solar arrays and both chemical and ion electric propulsion systems for station keeping. That module is currently slated for launch in 2022. Joining it will be the 4-ton European system providing refueling infrastructure and telecommunications, or Esprit module, which would provide additional xenon and hydrazine capacity, additional communications equipment, and an airlock for science packages. Then there's the American Utilization Module, a small pressurized space that would allow the crew to ingress on the very first mission to the Gateway assembly sequence. It would initially store additional food and will be launched alongside Esprit. Then there will be the International Partner Habitat and the US Habitat, which will be the 2 habitation modules providing at least 125 cubic meters of general living space for the crew. There will be Gateway Logistics modules, which will be used to refuel, resupply, and provide logistics on board the space station. Finally, there's the Gateway Airlock module, which will be used for performing extravehicular activities outside the space station and to berth deep space transports. A number of lunar lander vehicles are also being planned to shuttle from the Gateway to the lunar surface. These will include Heracles, a robotic lander proposed by a joint ESA, JAXA and Canadian Space Agency team. Heracles stands for Human Enhanced Robotic Architecture and Capability for Lunar Exploration and Science. And yes, ladies and gentlemen, I think we have a new winner when it comes to tortured acronyms. The lander system will involve dispatching an 11-ton lunar lander from Earth aboard an Orion 6 rocket, which would first land on the Moon, before an ascent module then heads to the Gateway station. Ascent modules would be reusable and will be paired at Gateway with fresh lander modules dispatched from Earth. Another even bigger lunar lander project is being developed by Lockheed Martin. This concept involves a 22-ton reusable manned lunar lander capable of carrying up to a ton of payload and a crew of 4 on missions to the surface lasting 2 weeks before returning back to Gateway for servicing and refueling and then reuse. Then there's NASA's own idea for a lunar lander called the Advanced Exploration Lander. It would be a 3-stage vehicle that would allow departure from the Gateway space station, taking a crew of 4 down to low lunar orbit, and then separate, after which the descent module would handle the rest of the journey down to the lunar surface for a 2-week stay, before an ascent module attached to the descent module would then return to the space station. Both the ascent and transfer modules will be designed for reuse, with operations starting in 2028.
Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the Moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
This is Space Time. Still to come, a joint Russian and Chinese moon base to be operational by 2035, and SpaceX launches a new European spy satellite. All that and more still to come on Space Time. Russia and China say they'll start work on the new joint lunar space station in 2026, with basic infrastructure construction expected to be finished by 2035. Beijing and Moscow will sign formal agreements on the project before the end of this year, with the final lunar construction site to be selected by 2025. Construction will take almost a decade, with cargo and equipment being transported to the lunar surface by unmanned automated spacecraft. The first human inhabitants are expected to arrive at the new moon base by 2035, possibly 2036 at the latest. This is Space Time. Still to come, a new European spy satellite launched by SpaceX, and the spectacular constellation Orion, and the nearby massive ticking time bomb of Betelgeuse are among the highlights of the February night skies on Skywatch. Well, it took several attempts, but SpaceX has finally launched Italy's COSMO-SkyMed second-generation 2 Earth observation satellite. The mission was flown aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. The flight had to be scrubbed 3 times because of bad weather, and a 4th time because the Royal Caribbean cruise ship Harmony of the Seas sailed into the restricted area despite warnings by the US Coast Guard. After the launch, the Falcon 9's core stage successfully returned to the ground, touching down on Cape Canaveral's landing zone 1.
COSMO-SkyMed is an Italian Earth observation satellite designed to help monitor the environment, including the prevention and management of natural disasters. Owned by the Italian Space Agency and the Ministry of Defense, it is the first in a constellation of satellites to be operated for both civilian and military purposes. The next event will be the internal flight computers taking over the launch countdown. Once the computers take over, they will execute stored programs and prepare the vehicle for liftoff.
Falcon 9 is in startup. Go for launch.
All systems are go for launch, so let's listen into the terminal count.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff. In Bosca al Lupo. Go Falcon, go Cosmo.
Vehicle is pitching downrange. M1D chamber pressures are nominal.
Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying the COSMO-SkyMed satellite to a polar sun synchronous orbit.
Power and telemetry nominal.
Now, during ascent, we tilt the engines, and that's what we call gimbaling, and that turns the rocket horizontally. That's what we call a gravity turn. We're still going up, but we're now also heading horizontally away from the launch pad. The rocket typically needs to go
Falcon
about...
9 is supersonic.
We need to go about 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth.
Max Q.
And there we heard the call out for Max Q. We have now passed through the maximum aerodynamic pressure. This is the largest structural load on the vehicle. And with that, we do have 5 events coming up back to back. They'll happen within seconds of each other. And these events include the first stage making its way back to landing zone 1 today. So we'll have MECO, main engine cutoff, stage separation, a flip of the first stage, SES-1, or second stage engine start 1, and then followed immediately by the boost back burn on the first stage.
MECO. Stage separation confirmed. And back ignition.
Stage 1, boost back startup.
Now in a few seconds here, we should see the fairing halves on the second stage being deployed.
Stage 1, boost back shutdown.
Grid fins deploying.
Fairing separation confirmed.
Fairing halves have deployed. They're now making their way back to Earth, and we will attempt to recover them with our recovery vessel named Bob today. And for the entry burn, we relight 3 of the 9 M1D engines, and that starts with the center E9 engine, followed by the E1 and E5 engines. And that helps to slow the vehicle down as it passes back into the Earth's atmosphere. And we need to slow the vehicle down to reduce...
Both vehicles continue to follow nominal trajectories.
Great call-outs. Everything's looking nominal. And for that entry burn, we do need to slow down the vehicle to reduce the re-entry forces. That helps us to recover and reuse the first stage. Again, today, we are attempting to land at landing zone 1. This is back at land. We need 3 burns to get us there. We've already completed the boost back burn, and we're coming up on the entry burn here, and stage 2 is still looking great.
Stage 1, entry burn startup.
Again, this helps to slow the vehicle down as it re-enters back into the Earth's atmosphere. It's only about a 20-second burn.
Stage 1, entry burn shutdown.
And we heard that call out for entry burn.
Stage 2 FTS has saved. Both vehicles are on nominal trajectories.
Stage 1 transonic. Stage 1 landing burn. Stage 1 landing like deployed. Stage 1 landing confirmed.
Touchdown of Falcon 9 at landing zone 1. This is our 104th recovery of an orbital class
Terminal
rocket,
guidance.
and that includes first stage landings for both Falcon 9 and Falcon Heavy. And speaking of Falcon Heavy, today's flight marks the first time that we have reconfigured a Falcon Heavy side booster to a Falcon 9 mode, which is pretty awesome. Now next up, we will have the shutdown of the MVAC on the second stage. It's coming here in about 10 seconds, and that is called SECO-1. Or second stage engine cutoff 1.
SECO 1.
Just heard that call out for SECO 1. Just waiting for
nominal orbit insertion.
And there it is. We got a confirmation of good orbit. Now, the mission isn't over just yet. The second stage is now embarking on its first coast phase. And after the coast phase, we will light that MVAC engine for a second time around T plus 56 minutes.
The constellation of small satellites for the Mediterranean Basin Observations, or COSMO-SkyMed second generation 2, is designed as a follow-on spacecraft building on the original constellation of 4 COSMO-SkyMed satellites. The spacecraft are dual-purpose scientific military Earth observation missions using a full polarimetric high-resolution synthetic aperture radar covering intelligence gathering, surveillance, target acquisition and reconnaissance operations. Built by Thales Alenia Space, the 2,230-kilogram spacecraft was placed into a 619-kilometer high sun-synchronous orbit.
The COSMO-SkyMed second generation is a constellation of 4 satellites equipped with a synthetic aperture payload able to acquire images in any part of the Earth's surface with an unprecedented resolution and image quality. The COSMO-SkyMed satellites, like the optical systems, are able to operate during the night and in presence of clouds. This is thanks to the specific frequency used for the acquisition. The antenna is totally new and is able to acquire simultaneously images at a very big distance between them, and the data acquired contain a lot of new information with respect to the past generation. For the better use of the satellites and the exploitation of data, we have developed a new control center and processing center in Italy. This will enable the development of new science and new services application for the benefit of citizens, institutions and entrepreneurs.
COSMO-SkyMed constellation is not only a very important technical instruments in the field of Earth observation, but is also an important support to the strategy of Italy to international collaboration. Thanks to COSMO-SkyMed over the years, and even more will be in the future with the enlargement of the constellation, we can establish collaboration with other countries to share the use of data provided by the constellation and to enlarge the coverage of the planet with other instruments offered by partners. I'm talking about so far, for example, Argentina. We plan in the future to do collaboration with Israel and so on. Also very important is the fact that we use COSMO-SkyMed as third-party contributor to the Copernicus program of the European Space Agency and the European Union. In this way, we offer important strategic and precious data to collect with our constellation, also to other partners, to other producers of data, for the benefit of Europe and the rest of the world.
The launch follows on from the December 2019 launch of its sister spacecraft, the COSMO-SkyMed second generation 1. That was aboard a Soyuz 21B rocket equipped with a frigate upper stage, which was launched from the European Space Agency's Kourou spaceport in French Guiana. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February is the second month of the year in the Julian and Gregorian calendars. It's also the shortest month of the year and the only one which is a length less than 30 days. The month is 28 days in common years and 29 in leap years, with a quadrennial 29th day being called a leap day. This additional day every fourth year is needed to keep the calendar year synchronized with the astronomical year. Because seasons and astronomical events don't repeat in whole numbers of days, calendars that have the same number of days in each year tend to drift over time with respect to the event the year is supposed to track. By inserting an additional day every fourth year, this drift can be corrected. The extra days occur in years which are multiples of 4, with the exception of years divisible by 100, but not by 400. Similarly, in the lunisolar Hebrew calendar Adar Aleph, a 13th month is added 7 times every 19 years to the 12 lunar months in its common years, in order to keep its calendar from also drifting through the seasons. And in the Baha'i calendar, a leap day is added whenever it's needed, in order to ensure that the following year begins on the vernal equinox. The length of a day is also occasionally changed by the insertion of leap seconds into Coordinated Universal Time, or UTC, more often referred to as GMT or Greenwich Mean Time. This is needed because of the variability in Earth's rotational period. But unlike leap days, leap seconds aren't introduced on a regular schedule, since the variability in the length of the day is not entirely predictable. Okay, let's turn our attention to the sky now. And throughout most of February, sky watchers in the southern hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as two separate streams, although they rarely produce more than 1 or 2 meteors per hour. They usually peak around February the 8th, and to see them at their best, you really should be looking towards the east a few hours before dawn. Okay, looking north now, and high in the sky is the famous constellation of Orion the Hunter. Orion is one of the best known and most recognized constellations in the sky. In Greek mythology, Orion was the son of a Gorgon and Poseidon, who was also known as Neptune, the god of the sea in Roman mythology. Orion was a mighty but egotistical and conceited hunter, who once boasted that his skill would allow him to kill all the world's animals. So the earth goddess Gaia sent Scorpius the scorpion to kill him and save the animals. Orion was stung in the shoulder, but then the healer Ophiuchus intervened to save him and crush the scorpion. Both Orion and the scorpion were then placed in the heavens to play out the story each year, with Scorpius rising in the east as the defeated Orion sets in the west. Now, a variation of this fable speaks of Orion getting a little bit too close to Artemis, the goddess of chastity. Now, her brother Apollo didn't approve of this relationship and tricked Artemis into testing her skill by shooting an arrow at a distant speck on the ocean. What Artemis didn't know was that speck was actually Orion, swimming to escape the giant scorpion created to kill him. When Artemis discovered what she had done, she placed Orion's body in the sky as the stars we see today. Similar variations to this story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, the god of the underworld and of regeneration. The very earliest depiction that's been linked to the constellation Orion is a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists have estimated that it would have been fashioned somewhere between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including ancient Babylonian star catalogues dating back to the Late Bronze Age. Orion's easily identified by its rectangle of 4 stars, surrounding a central trio of stars in a row, which form Orion's belt. And hanging from the belt are the stars which make up the Sword of Orion. To those of our listeners in the southern hemisphere, Orion appears to be upside down, with the sword on his belt pointing upwards. And if you look really carefully, you'll notice that the middle star in the sword looks a bit fuzzy. That's because it's not a star, but rather a huge star-forming region known as Messier 42 or M42, the Great Nebula in Orion. Located some 1,344 light-years away, M42 is the nearest large star-forming region to Earth, containing hundreds of newly forming stars and protostars. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The Orion Nebula is more than 24 light years across, and it contains as much mass as 2,000 suns. It's one of the most scrutinised and photographed objects in the night sky, and is among the most intensely studied celestial features. The Orion Nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of nearby massive stars in the nebula. The Orion Nebula contains a very young open cluster known as trapezium due to the asterism of its 4 primary stars. The trapezium itself is a component of the much larger Orion Nebula cluster, an association of around 2,800 stars within a diameter of just 20 light-years. The brightest star in the constellation of Orion is the semi-regular variable red supergiant Betelgeuse, which represents the scorpion's sting on Orion's shoulder. Currently known as Betelgeuse, and commonly referred to by the public as Betelgeuse, don't say it 3 times, the names are both tortured mispronunciations of the original Arabic name Ibtal-Yawza, meaning the hand of the big man being Orion the Hunter. Located some 643 light-years away, Betelgeuse is the 9th brightest star in the night sky. And it's big, really big. In fact, red giants like Betelgeuse are among the largest stars in the universe, at least in terms of volume, although they're by no means the most massive or luminous. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times that of the Sun, and it shines with some 100,000 times the Sun's brightness. If it were placed at the location of our Sun at the centre of our solar system, its visible surface would extend almost as far out as Jupiter, engulfing the orbits of the planets Mercury, Venus, Earth and Mars, as well as the main asteroid belt. Betelgeuse began its life around 10 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there are spectral type K orange stars, and the coolest and least massive stars are spectral type M red stars, often referred to as red dwarfs. Each spectral classification system is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then Roman numerals added to represent luminosity. Put them all together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. Red supergiants are fascinating objects. After spending billions of years fusing hydrogen into helium in their core, a star's core hydrogen supply eventually runs out, and the balancing act between nuclear fusion pushing outwards and gravity pushing inwards stops, with gravity winning. The entire mass of the star then comes crashing down onto the core. This causes a dramatic increase in the core's pressure and consequently temperature. Things get hot enough to trigger what's called a helium flash. This causes the core helium, which has been created in the star, to begin fusing into carbon and oxygen. At the same time, the hydrogen-rich region around the stellar core has now moved down into that region where the temperatures and pressures are high enough for hydrogen fusion into helium to commence in a shell around the core. Now, as all this is going on, the increasing core temperature results in an increasing level of luminosity, and the resulting radiation pressure from the shell burning causes the outer diffuse gaseous envelope of the star to expand to hundreds of times its previous radius. And as the now bloated star's chromosphere or visible surface moves further away from its core, it cools down, turning redder. Hence the star has become a red giant. Small stars like the Sun eventually lose their outer envelopes completely, which continue expanding outwards as planetary nebula. This ultimately exposes the star's white-hot stellar core as a white dwarf, which is then left to slowly cool down over the eons of time. However, stars with masses more than around 8 times that of the Sun experience a very different fate. Unlike the Sun, their fusion cycle doesn't end with helium in the core fusing into carbon and oxygen. They have enough mass to fuse carbon and oxygen in their core into progressively heavier and heavier elements through a different process, while the shell burning around the core also fuses progressively heavier and heavier elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become supergiants. Eventually they'll explode as core collapse supernovae, ending up as either super-dense strange objects called neutron stars, or even stranger objects called black holes, singularities of infinite density and zero volume, where the laws of physics as science understands them no longer apply. It's too early to tell whether Betelgeuse's ultimate fate will be as a neutron star or black hole. As a red supergiant, Betelgeuse is reaching the end of its life, and it's expected to explode as a core collapse or Type II supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean a million years from now. When it does explode, Betelgeuse will temporarily outshine all the other stars in our galaxy, and it will be clearly visible in the daytime sky on Earth. The last star to be seen by humans to go supernova in our galaxy was Tycho star. That was in 1572, and that was before the invention of the telescope. Diagonally opposite Betelgeuse, marking Orion's left foot, is the blue supergiant star Rigel, the second brightest star in the constellation Orion. Rigel is part of a triple or possibly quadruple star system with 3 or 4 small companion stars. The primary star, Rigel A, is located some 863 light-years away and has about 23 times the mass of the Sun. The star's already exhausted its core hydrogen supply, and it's swollen out to between 79 and 115 times the Sun's radius, and is somewhere between 120,000 and 279,000 times as luminous. Like Betelgeuse, it's now fusing progressively heavier and heavier elements in its core, meaning it too will soon go supernova. Rigel A pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Alpha Cygni variables are variable blue or white supergiant stars which exhibit non-radial pulsations, meaning some areas of the star's surface are contracting while others are expanding. This causes irregular variations in brightness due to beating of multiple pulsation periods. The pulsations are likely caused by iron opacity variations and typically have periods ranging from several days to a few weeks. Rigel A's companion star Rigel B is some 500 times fainter than the supergiant, and it's only visible with a telescope. Rigel B itself is a spectroscopic binary system comprising 2 main sequence blue-white stars. Main sequence stars are those happily fusing hydrogen into helium in their core. And spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, at least from our viewpoint on Earth, by their spectroscopic signatures. The 2 stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun, respectively. And one of those stars, Rigel BB, itself may be a binary. It appears to have a very close visual companion, Rigel C, of almost identical appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It has an estimated age of approximately 25 million years. Now that's old enough for a star of this mass to have consumed much of the hydrogen in its core and begin the process of evolving away off the main sequence into a blue giant. One of the most stunning nebula in Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just south of the star Alnitak, which is the furthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1,500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most identifiable nebulae simply because of the shape of its swirling clouds of dark dust and gas, which really does bear an incredible resemblance to a horse's head. To the west of Orion's belt, you will see a V-shaped grouping of stars which represent the head of Taurus the bull, who in Greek mythology was changed by the god Zeus to carry Princess Europa off to Crete. The V is also part of a large open star cluster known as the Hyades. One of Taurus's eyes is the giant orange star called Aldebaran, or the Follower, which is located around 65 light-years away and has about 1.5 times the mass of the Sun. Aldebaran is thought to contain a number of Jupiter-sized planets. Aldebaran's already evolved off the main sequence, having exhausted its core hydrogen fuel supply. It follows the Pleiades, or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located in the constellation Taurus, the Pleiades is one of the nearest and youngest open star clusters to Earth, located just 443 light-years away. There's a story in Greek mythology which tells us that Orion fell in love with the Seven Sisters and pursued them for a long time. Eventually, Zeus turned both Orion and the Pleiades into stars. Interestingly, a similar story is told in the Aboriginal Dreamtime culture of the Great Victoria Desert region near Aldeer in outback South Australia. Orion's described as a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. In Orion's right hand is a club filled with magic fire and represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hades star cluster, taunts Orion, standing in front of him. She defensively lifts her foot, which is the star Aldebaran, and is also full of fire magic. And this causes Orion great humiliation, putting out his fire and allowing the 7 sisters to escape. Now, one of the interesting facts about this ancient Dreamtime story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a 400-day period. The Pleiades' 7 sisters story is remarkably similar to legends found in many other cultures around the world, and which haven't had any contact with each other for tens of thousands of years. The Pleiades' 7 brightest stars can be seen with the unaided eye, hence the 7 sisters nickname. But this spectacular open star cluster actually consists of more than 100 stars. Now, if you follow Orion's belt to the east, it brings you to Sirius, one of the nearest and brightest stars in the sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. It's the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the Hunter. To the ancient Egyptians, Sirius was known as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced by Osiris as lord of the underworld. Sirius also represented the god Isis, and ancient Egyptians initially based their calendar on the star's yearly motion across the sky. Now, if you look high in the southern sky in February, you'll see the star Canopus, a white supergiant located 313 light-years away, the second brightest star in the night sky after Sirius. In Greek mythology, Canopus was the helmsman of the Greek king Menelaus, and the brightest star in the constellation Carina, which represents the keel of the boat used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Puppis. Also in the southern skies this time of year, you'll see the large and small Magellanic Clouds, which are 2 dwarf galaxies orbiting our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori, and served as important navigation markers. They're named in honour of the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan himself didn't complete the circumnavigation. He was killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead and is about 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers have classified it as a disrupted barred spiral. It's around 14,000 light-years in diameter and contains about 10 billion times the mass of the Sun. Located slightly lower and to the west, you'll see the Small Magellanic Cloud, which is located around 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that it too was once a barred spiral galaxy, but had become disrupted by the gravitational tidal perturbations of the Milky Way. Jonathan Alley, the editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the February night skies.
G'day, Stuart. Yep, February, really nice time of the year for stargazing if you live in the part of the world where I am, which is sort of middle southern latitudes on planet Earth. For our friends, in the far north of the planet, a bit different up there, cold, snowy, rainy, wintry sort of thing, but you're copping it at the moment.
Blizzards in Boston and New York.
Blizzards, really? Yeah, well, you can keep that. I was just thinking, I've got a friend who lives in London, and she said it's about 4 or 5 degrees there, and where I am, it's actually not that hot at the moment. We've had a few days of 30 degrees or so. So I'm thinking, well, there's about 25 degrees difference. But, when you think about it, at the moment we've got some parts of the world that are 40 plus degrees, and there are plenty of other parts of the world that are minus 40 degrees. So that's, an enormous range of temperatures from one end of the planet to the other. Can't really imagine an 80 degree difference, 80 degrees Celsius difference in temperature. It's just really quite amazing. But anyway, where I am at the moment, it's really good stargazing weather because it's warm nights, you've got clear skies, lots of good constellations and other things to see as well. So at this time of the year, if you go out in the early evening, you'll see the Milky Way, and it's stretching right across the sky from the south to the north. Milky Way, of course, is just our galaxy seen from the inside. And when you look up there with the unaided eye, you can't really make out too many individual stars. It just looks like this fuzzy band going across the sky. But if you get some binoculars or a telescope onto it, which is what some early astronomers eventually did when they got their optics, they could see that they actually were made up of lots of little stars. This Milky Band across the sky is actually made up of lots of little stars, which is our galaxy from the inside. And so there are lots of bright stars and lots of beautiful deep sky objects and clusters of stars in the nebulae all through the Milky Way. You find most of them through the Milky Way region of the sky because you're looking into our galaxy there, whereas if you look at 90-degree right angle to the Milky Way, you're looking sort of out through the thinnest part of our galaxy, then out into deep, deep space in between the galaxies where there really isn't much to see. Now, down in the south, for us here, we've got the Southern Cross, and it's down low at the moment, this time of the year. And above it are three constellations that we've mentioned a few times on the show that used to be joined up into one, and they were split up years ago. It used to be called Argo Navis, the ship of the Argonauts of mythological fame. But it got divided into three, into Vela, which is the sails of the ship, and Carina, which is the hull and the keel of the ship, and Puppis, which is the poop deck. And there actually was a fourth little constellation that gets forgotten quite a lot, and it's called Pyxis, Pyxis, and that means maritime compass for navigating. So that used to be Argo Navis. Constellations, by the way, I've mentioned constellations. The constellations are just join the dots affairs, from one star to another to make up a shape. They don't actually mean anything scientifically, constellations. It's just where ancient civilizations put their mythological characters and other people.
Depends how much wine they've
things
had.
up in the sky. Yeah, exactly. Yeah. And they did like their wine, let's face it. Now, beyond Puppis, one of these constellations that was in Argo Navis, and high overhead in February is the constellation Canis Major, which is the constellation of the large dog. Canis, dog, major, large, so the large dog. And there's also a Canis Minor, the small dog, which is not too far away. The brightest star in Canis Major and the brightest star in the night sky overall is Sirius. And the brightest star in Canis Minor, not too far away, is called Procyon, and it's the eighth brightest star in the night sky. I mean, Sirius is really big and bright. You can't really miss Sirius. It's when it's up there, if you look around and think, what's the brightest star in the sky? That's it. Well, that's Sirius, and you're looking at the constellation Canis Major. To continue along the Milky Way beyond that constellation, you get to Orion, the Hunter. I've spoken about Orion many times. And you keep going, and you get to the constellations Gemini and Taurus, which are full of really good deep sky objects, things like star clusters and nebulae. Get some binoculars onto them is all you really need to start with, and just sweep through this sort of area. And you come across all sorts of wonderful little sights of groups of stars and things. It's really wonderful. When you're starting off in astronomy, to just sweep through areas like this with a pair of binoculars and discover these things for yourself, and put yourself in the shoes of the people hundreds of years ago when the first telescopes were coming around and people were seeing this stuff for the very first time. So when you see it for the very first time, it's pretty wonderful as well. Gemini is actually pretty easy to spot because it's got two bright stars that are fairly close together. They're called Castor and Pollux. And Taurus is easy to spot too because it's sort of a wedge-shaped or triangle-shaped group of stars in its head. And it's a group of stars they're called the Hyades. And you can see many of these stars just with your own eyes, but again, a pair of binoculars really reveals a lot more of them. So that's the tour of the Milky Way for February. Now, what about the planets? At the moment, first up, we've got Jupiter. Now, Jupiter is very low in the western sky after sunset. I mean, really low at the moment. And it's getting lower and lower each day because in an orbital sense, it's heading around on the other side of the sun from where we are. So, therefore, when we look in that direction, we're looking into the solar glare, and it's about to disappear into the solar glare as it really gets around to the other side of the sun. By the middle of the month, you basically won't be able to see it. But it will come back. It'll be back in the morning sky. You'll be able to see it before dawn, above the eastern horizon, before sunrise, towards the end of April. But between middle of February and end of April, you won't be able to spot it. Now, the other bright planets, Venus, Mercury, Mars and Saturn, these are all morning objects at the moment. can see them in the eastern half of the sky before the sun comes up, so you've got to be an early riser. They'll be slowly shifting their positions relative to each other during February, but will remain fairly far apart. In March, a few of them will come together in little groups of 2 or 3, and that'll be pretty good. We'll talk about that next month. But get out, if you're up early in the morning before sunrise, or if you're up really, really late, have a look. You can't really miss them. Venus is really big and bright. Next brightest one's Mercury, then Saturn, and then Mars. And Mars is pretty easy to spot, even though it's not too bright, because it's got this sort of ruddy, reddish, orangey sort of colour, whereas most other things in the sky just look white. And the moon actually will be going through that area as it trundles along in its orbit around the Earth. The moon will pass by each of these planets in turn in the last few days of February, or the last few nights, I should say. So if you've got a digital SLR camera and a nice wide-angle lens, perhaps, you should get out and see if you can get some shots, because it's going to look really nice.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.